Okay, thanks for coming, everyone who's here. So here, let me show my screen. We'll try to move a bit faster today because we have a lot to cover. Hopefully it'll be interesting. Can everyone see the slide?
Yes.
All right, great. Okay, so the premise today is like we're gonna look at like an example web application and think about what it means to scale our application outputs. And right now we're being very vague. We haven't described what this web application is or even what scaling means, but that's going to kind of be the focus of our discussion today. And indeed, I really hope that this will be a discussion. I've kind of tried to make it as interactive as possible, at least in the sense that maybe you'll still get something out of it. So please feel very free to jump in and interrupt me and participate in what I'm talking about, because again, I think I mentioned this, what was it, like almost a month back now when we did our first session. A lot of what I'm saying is kind of my opinion and like what I've seen, but of course, this is inherently biased, and it's very reasonable to be like, oh yeah, it's okay. Look, what you're saying, maybe you think it's right, but in reality, it's very wrong. This happens all the time, so we need to have these kinds of discussions. Okay, so yeah, I'm going to introduce this example that we're going to use throughout today's discussion. We're going to talk about what it means to measure performance in an application and what it means to scale up an application with regards to some measure of performance. And then we're going to dive a little bit more deeply into a couple of examples on how you may want to architecture your this application that I'm going to present, so as to hit like some kind of features in an effective way that you want to. So again, very vague. We'll get to this in a minute. All right. So before we start, again, I want to emphasize that if you can, please leave feedback for this and other talks. It's very helpful for us, especially when we have kind of low attending talks like this. It's useful if we can get a sense of like, okay, here's what you're interested in, and we can kind of more tailor the next two sessions towards what you're interested in, rather than just being very generic, which is not useful for if it's just a small number of people. Okay, enough about this. Let's move on. So the premise today is we're going to talk about how we would build web applications similar to Lichess. So I don't know if you guys actually stop sharing my screen for a second so I can reshare my entire. You can see this?
Yeah.
All right.
I see you.
So, so I don't know if you guys have seen Lichess, but it's basically like this web application where like you can go on and you play some chess games with people. So it's like a very nice site. You can go play around with it if you want, but like we want to do something similar. And so the key tenets that we want to have is like we want to give people the ability to play live one-on-one games with each other. We want to show live standings. So like here, there's like a leaderboard across like different chess variants. We want people to be able to see other games that are currently being played. So that's what you see right here on the left. And we want some kind of chat capabilities. So in Lichess, like you can start up a game and you can like chat with the other person while you're playing. All right. One sec. Okay. So let's like just very quickly talk about like on a very high level what this architecture looks like. Of course, it's the classic client server model. You get this front end that we talked about in the first session, this back end that we talked about last session, and basically they communicate between each other, right? Like on the front end, you have the stuff that the components required to actually display the UI. On the back end, you have like the majority of the logic actually responsible for handling all the business logic of this chess application, right? So pretty standard, nothing very exciting here. Again, I'm just pulling another diagram up from the website that orchestrates Lichess's architecture. But again, there isn't much interesting here. It's just saying, okay, like, you have some entry point that you get requests from. You have like some logic encapsulated, in some giant chunk of code, and this talks to a database, and that's how the communication flows between all parts of the web application, right? So again, nothing very interesting or very fancy here, but if you do have questions about this, like, please let me know. I hope everyone is following me up to this point. So it's just client server model. The only addition that we have is like, we want also these four features, right? Okay, so now we're gonna like shift gears for a second. So I'm just introducing this like chess application, like, keep it in the back of your mind. We'll get back to it in a second, but like now I want to kind of like step up a layer and say, okay, like, if we think about how we're going to build an application like this out, first we have to like understand what it means, like what it means to like even try to scale your application to something large, right? So there's two questions we need to answer here. Is like, first of all, what does it mean to like scale an application? And second of all, like, when should we want to scale our application, right? So like at the very base level, we can kind of think about it as like, okay, I have something that works and I want to improve it. Okay, but we need to define what it means to like improve something, and we need to define when we should improve this. So does anyone have any ideas about like when we would quantify both of these things?
So the scaling that I can think of is, for example, when you initially assume, for example, to accommodate maybe 5,000 users, and then it starts going out of capacity. Maybe you need to improve the amount of users you can handle. So you need to scale the amount of traffic that you can handle. Maybe yeah, that kind of stuff. I think that this kind of stuff I know.
Yeah, that's a great answer. Anyone else have any comments here?
What about like in general, when you have a lot of people wanting to use the same thing at the same time?
Sure, exactly. So I think both of you make great points there. And what I would also add is like, it's not only that like you have some kind of demand, it's that you're not able to meet that demand, right? That's like the deciding factor here. It's like, for example, if you're, let's say you're a single person and you go out and you live in a city and you buy yourself like a scooter or a motorcycle, right? This works great, but when you have a family, like all of a sudden a motorcycle is not going to work anymore, right? Because if you have two kids, where are you going to put them? Probably not on a motorcycle, right? And so you have to say, okay, like it's time for me to move on to a car, right? And so in software, we have a similar kind of thing. If I build something out and there's like 10 people using it, that's all fine and good. But if all of a sudden like it reaches the front page of some your favorite like news site or whatever, all of a sudden you have like 100,000 users on your next day, and it's like, well, now I have to come up with something that's gonna work a lot better. And so this quantification is important, right? It's not like we're just kind of arbitrarily making our applications longer or arbitrarily like making them more complex. You can do that, but I don't think that's a very good use of your time. But on the other hand, when something comes along and all of a sudden like you do need a stronger and more well-designed and larger application to support a larger volume of traffic, that's when you need to like start thinking about, okay, how do I like actually improve this thing? Okay. And so there's not only is there this like idea of scaling up, there's also an idea of scaling down, right? If all of a sudden your application is no longer on the front page of New York Times or whatever, and it drops down by 50%, probably it's not a good idea to like keep up as many servers as you have running currently, because then you're just wasting a lot of money, right? And so if we kind of like kind of squint our eyes at this a little bit, it's like, well, all this really depends a lot on the context that we're talking about, right? It depends to figure out like how we should design our application to like fit a larger need, for example, like a larger volume of users. we need to think about like what our application is doing and what the needs of our users on that application are, right? And for that, we need to like figure out some good measurements to use, right? And I hope that this is making sense, right? Like it's not like we're just saying, okay, like, you know, I'm not going to put my two kids on my motorcycle, so instead I'm going to get a car. But you have to like think about, okay, what kind of car do you want to get? Because you're probably not going to get a Lamborghini, right? It's not like the safest thing for your kids. So you want some kind of measure of safety, right? So for example, maybe you decide to measure safety by like, all right, well, like what's the potential for human damage if I get into a car accident, right? Like this is a measurement that's well known. And so in a similar kind of vein, if we're designing like some kind of web application, you're to say, all right, what do our users care about? How do we measure how do we measure like those factors, and how do we improve upon them based off those measurements, right? So again, we're still being kind of vague, but I hope, let me know if you're lost at this point. Okay. All right, so let's dive into this a little bit deeper. So again, like I made the point on this last slide, this idea of like what it means for your application to be performant, what it means for your application like to be usable for your users depends on the application, right? Like there are very many answers that you can say for what productivity for an application means, and again, it's all dependent on the application itself. But one very common like metric that we might make is this idea of latency, right? So if you haven't heard of latency before, latency is a measure of the time it takes to process some request, right? So for example, let's say I'm on my browser and I go to some web page like youtube.com or something. The latency of the response, the latency of the response from youtube.com is exactly the amount of time it takes me to load youtube.com, right? So this is a very simple metric. It's just saying how long does it take me to do something, right? And to some extent, we might say, okay, well, if I have something like youtube.com, or let's say even more dramatically, let's say you're trading, you're trading stocks on a very high frequency, like on one of these stock markets, right? You want to make sure that when you buy and sell stock, it happens very quickly, because especially if you're doing something like day trading, the prices can fluctuate a lot. So you want this to be near instant, right? Or similarly for like airplane radar, right? You don't want your radar to be off by too much time, because then you're going to lose track of what you're tracking in the sky. So you want these things. You want the responses to your actions to be very quick. That's what. So in those kind of situations, a low latency is good. But in general, latency is just how long does it take to do something, right? There's also another measure called throughput. And maybe the best way to explain this is like, imagine you go to a restaurant and you want to measure like how many customers you can seat and dine in an hour, right? So if you have only one table in your restaurant, that number is going to be very small. Maybe you can serve like one or two customers an hour if you just have one table in your restaurant, right? If you have 30 tables, certainly that number is going to be much higher, right? And so the measure of throughput is like the amount of units of work that you can do over some time period. So in this example here, let's say our server can process 3 requests from users in an hour, then our throughput is like 3 units of work, in this case, requests per 1 hour. Now, of course, this is kind of a fictitious number because 3 requests an hour is abysmal. But again, just as an illustration, that's what we're measuring with throughput. We're saying how much work can you do over a given period of time, right? And so I guess maybe as an example of something in real life, like maybe a good example here is something like Brightspace, right? So if you think about what Brightspace is, like it has this demand where it needs to serve, for example, at Vanderbilt, it needs to serve like 6,000 students every single day. Now, maybe you don't have to do like everything super quickly on Brightspace, but you do certainly have to be able to like handle 6,000 people logging into it at the same time or around the same time, right? Okay, so any questions so far? All right, so these are two metrics we presented. And now the claim that I'm going to make is like, in fact, these two metrics that we have are metrics that you have to trade off significantly. Like it's not, it's very difficult to build things that just have both a very low latency and a very high throughput, right? Because what that's saying is like you can do something very, very fast, and also you can do everything at once, right? Like that's how I would think about that analogy. And if you think about it intuitively, well, it's like the kind of person that can stay up all night and also wake up the next day and go do a workout, and it's their best workout ever. Now, certainly, some of us may have days like that, and certainly, there are a lot of people that can do this kind of thing, but I would be hard pressed to say that it's sustainable. And moreover, I would say that it's not, it's not very enjoyable in the long term, nor is it really like what a human is designed for, right? And so in a similar way, as I'm about to show you, it's very difficult to build a web application that both has low latency and high throughput just because of what their demands are. Okay, so let's take this example that we have right here. Let's just say like this graph at the bottom represents the load on some web server over some time period. And here I've just split them into chunks for convenience. Okay, so by load, I just mean how much work the web application is having to do, right? So the first question I want to ask is I want to segment each of these time chunks as either having low latency or high throughput. Now you can argue like, okay, some of them don't have either, but let's just say each of these chunks either has low latency or high throughput. So does anyone want to guess which chunks have low latency and which ones have high throughput?
I guess when the load is low, we can expect low latency because there aren't many requests, so each request is processed pretty quickly. And when the load is high, the throughput might be higher. I'm just speculating. I'm not really sure.
Yeah, I mean that's exactly correct. So I mean actually I haven't given you a lot of data, but based off what we just see here, I think that's like a reasonable conclusion. So what Ilya is saying is exactly correct. When our load is very low, that means there's a lot of, okay, let's kind of I forget the word, but let's like humanize this for a second. Obviously, there's not like people doing, servers aren't people, but let's just suppose they are. Okay, so when the load is very low, you can kind of think about it as like there's a lot of like idle waiters standing by, and they're ready to serve anyone at a restaurant, right? So if you come in, like they're going to be with you almost immediately, right? They're going to help you out. Okay, but the problem is that like they're not doing much work during this idle period. In fact, they're not doing anything at all. Like they're sitting there waiting for someone to come through. And so if you think about it on a throughput measurement, that means that they're wasting units of work over a period of time. And so your throughput goes down. Does that part make sense? Okay, I'll take that as a yes. So there's low latency, but but also low throughput, right? On the other hand, like let's say we're looking at something like this time chunk 4. And in particular, let's look at this part right here where the load is very high. Now, of course, if I come into the, I have a chat message. So, okay, so Skandra asks, so is load directly related to throughput if it's effectively managed? Yes, yes and no. Okay, I'm kind of waving my hands here. There's actually a lot more to it because you can have very high load and still not be doing anything. But in general, yes. Like in general, I think this is kind of a good measure. So if you look at the web traffic for a site and you see that its traffic is very, very low over some time period, you can say, okay, responses there are going to be very, very fast. If the traffic is like 99%, the response time is going to be very, very slow, but maybe the throughput is high. This is like the reason, for example, like trying to think of a good example. So I guess kind of as a funny anecdote, maybe, I don't know if you all remember this, but in 2016, when Donald Trump won the US election, the day afterward, the Canada immigration site basically got DDoSed because everyone was hitting it, like, I guess, trying to look up immigration information on moving from the United States to Canada. And so there, the latency was very, very low if you were hitting the site, right? Because the server like didn't have any, the web application didn't have any space to handle your request coming in. But the throughput was very, very high because at the same time, it was kind of handling the requests for like 500,000 other people who were hitting that website at the time. So in general, I would say yes, like it's kind of a good measure, but you still have to be careful because I am waving my hands a little bit here. Okay, so let's kind of finish up with this high throughput discussion. I hope that answered your question, by the way, Skandra. If you want to follow up with that, please do. Okay, but with this high throughput scenario, right? Like what we're saying is like there's the amount of load here is very high, and so we're being pushed to work a lot. But again, that means that we're getting a lot of work through, right? So even though we might not be able, we might have to like if there's a new person that comes in, we have to say like, hey, hold on, I can't get to you yet. At the same time, we're doing a lot of other work that has already come in. So this increases the throughput, even though it also increases latency, right? And so this is exactly what this slide is just saying exactly what I just verbalized. And indeed, I hope that this makes clear that there's a conflict between these two things. And it's not the case, at least it's not easily the case that you can have both very low latency and very high throughput, right? Because we just saw if you optimize for one, you have to trade off the other. Okay. All right. So again, stop me if you have questions, but now I want to pose like another discussion question, which is to say, let's like consider each of these four features that we have in this like that we have in our back of our head chess application example, right? So we have these like live games that we want to be able to play. We have this measure of live standings, live display of like other active games and other active players, and this chat capability within games, right? And so for each of these, let's try to characterize whether it's a better measure to keep track of to try to optimize higher throughput or lower latency for each of these features. What do you all think?
I think it kind of depends on the time of the chess game. For example, like if you just have 30 seconds to make all of the moves, like each of the opponents has 30 seconds, latency is kind of important. But at the same time, we might want to allow a lot of players to play at the same time. So throughput might be important.
Any other responses? Okay, we have a couple of chat messages. I feel like anything live would need better latency. Low latency for 1v1 games so you can be quickly matched. Okay, yeah, so these are all great points, but Ilya kind of hit on the dot. I was kind of tricking you here. Again, like this is very context dependent. You have to like go figure out what do your users care about and then come back and say, all right, like here's where we should, like here's kind of the middle ground where we should be going for, right? You're not ever going to be like, okay, I just want 0 response times, but like everyone is standing idle all the time. Like all of our servers aren't doing any work. But there's one server that gets hit every time we have a request, and like then our response time is 0. On the other hand, you're never going to say like, okay, if you make a request, you have to wait an infinite amount of time, but also like then I'm not wasting any of my resources because my the servers that I have for my web application are always working. you're going to go somewhere in the middle, right? So you need to kind of make a judgment call, and it's very reasonable to go both ways. But I do also think that, I think if you kind of look at it from a 10,000 foot view, it's very reasonable to say, like, okay, if we're playing a live game or we're doing something like chat, we probably want to optimize for latency, because you want those things to be kind of instantaneous. It feels kind of weird, like if you make a move and then it takes a few seconds for that move to go through. Also feels weird if you're having a conversation with someone and, like, the spacing of the time messages, like, doesn't feel like an actual conversation, right? But for these other things, maybe it's not so much of a big deal. Like, if you have something like live standings, like, okay, maybe it's okay if it takes a minute or two for me to get the exact live score of what position I'm at, right? Because, like, when do you ever care about, like, I don't know, what's a good example? Like, when do you ever care about, like, what your GPA is exactly at this time? Like, almost never, right? So maybe it's okay to have a little bit of a higher latency there. Okay, and so the last thing I want to point out here is, again, what I said before is, like, at the end of the day, like, what we want is both a low latency and a high throughput. We can't have this, so we're going to kind of try to settle somewhere in the middle. And in fact, you're going to try to optimize for both of these things, right? Like, you're not just going to say, let's throw one out and just work on the other one. This is a very, like, active field of study in software engineering, and to some extent, I guess, computer science. The general advice that I've always heard is to optimize for latency first and throughput later. The reason is it's a much harder problem to build. To build like a fast design to begin with than to just, like, push more data through later, right? Like it's very easy to kind of, like, expand your pipes, but maybe it's not so easy to, like, redesign how all of them flow, right? So you can kind of think about this as, like, how roads are laid out in a city. Once you kind of settle on your road layout, it's not so easy to like rearrange how they all interconnect, but highway expansions happen all the time. Right, so you can open up more lanes, but you can't rework the road so easily. And if you're interested, here's, like, a nice link about this. I'll share the slides on this later on, but this kind of gives, like, a nice 1-page summary of the problem here. Okay, so do we have any questions at this point? Okay, I guess not. So let's move on. Oh, we have one. It's a chat message. What's load balancing and why is it important in cloud computing? This is something that we probably don't have time to get into today. Maybe we can do it next time. The short and quick answer is basically it allows you to distribute your traffic in a sort of more consistent manner, right? So, for example, let's say okay, so let's say you and I set up, like, a web application, and we're gonna have, like, 2 servers for it, right? We're gonna have one in the West Coast, somewhere in San Francisco, and one in, like, New York City, right? Okay, maybe not. Okay, whatever. So let's just say New York City. Okay, and at each point in time, like, a request gets directed to one of those locations, right? Now, the problem is that, if 90% of our users are in California, our server in California is going to get hammered all the time, right? But our server in New York might not be doing much work. And so you could say, like, okay, well, let's just put the server that's in New York and California instead, and then we have, then we can kind of, like, redistribute this load. And so you can do this manually, but it kind of breaks down very quickly because you're doing a lot of work. And so instead, what you can do is, like, you can put someone at the beginning of all this stuff that says, okay, come to me first, and then I'll kind of fan out where you're supposed to go from there. And so if we put some kind of third party in front of both these guys in California and New York, then we can say, all right, whenever you hit my service, like, go to this guy first. He's going to figure out like which server is the best one to choose based on like how much work they have to do, and some other metrics so they can kind of like distribute the load evenly across everybody. That's the idea there. But yeah, maybe we can get to that next time. That's not really what I want to go into this time, just because we're running out of time. Okay. All right, so if there are no other questions, let's move on. So another chat message. No worries. That's a great question. So sorry, I'm gonna go one slide forward and I'm gonna go back. Okay. All right. So I'm gonna set up like this problem. So we're gonna, for the rest of this presentation, we're gonna talk about our chess application that we're building out, right? And I'm gonna set up this problem that we're gonna have with our chess application. Okay. So we talked about before that like we have this homepage on our chess app that displays the active games going on. So here, like I kind of lie a little bit because there's only one game, but pretend there's like a list of like 100 games happening, right? And this worked all fine and great, but like the past month, we got our site got onto like chessweekly.com or something. I don't know if that's a real site, but like all of a sudden our growth exploded and there's 100,000 new users. And now, we've been looking at the metrics for how long it takes the homepage to load, and like it's super slow to load the homepage, especially for this part of the active games playing. And furthermore, like it's not only that, it also happens that like our servers responsible for getting active games are spending like 60% of their time actually involved in this work, getting active games. So like we kind of we think about like what's going on. We look like at our application model, and we see that like the way I gave it away, but all right. So we look at how a user, like how the UI gets the active games that are being played. It calls this get active games route to our server. The server is like, all right, database, you have all the games that have ever been played and are currently being played. Can you get me all the games that are being played right now? Where like the start time, yeah, maybe this is like a bad term, but basically just like if they're currently being played, give them back to me. And the server gives all those games back to the UI, and then the UI is like, yeah, all right, now I can just play them nice and pretty. Okay, so think about like 100,000 users doing this every time. Doing this every time they load our chess web page. What's like the big problem that's going to happen? Any ideas?
Maybe getting all of the stuff from the database takes a lot of time, because like there might be millions of records, and going through all of them and checking for the condition, it might take a lot of resources and time. And doing it for each of the 100,000 requests, it's painful.
Yeah, exactly. So Ilya is right on the dot. This process of like going through what Ilya said, like we could have millions of games, going through every single one and saying, okay, is it being played right now? Yes, no, and filtering out that way and sending all that stuff back. It's very expensive operation, especially like think about like the course of humanity. Like the time that we're living right now is like 0.0001% or something, right? It's kind of ridiculous, and certainly you're not going to have that many chess games, but you can kind of extrapolate this out, and you can say like, okay, maybe the amount of games that are being played right now are like 0.1 or 0.01% of the actual games that have ever been played. So you're wasting a lot of effort for almost no reason, right? Because you're going to throw the vast majority of these things out. And as Ilya says, once you have to start doing, like maybe this is okay if you do it once or twice, but if you do it 100,000 times, imagine doing this 100,000 times a day, right? Like you're going to be spending a lot of time just going nowhere, basically, right? So of course it's going to get very expensive, and you're going to see the results of this. Okay, so we kind of know what the problem is here. of course, the real thing we care about is like, can we make this better? Okay, so now we're going to pose another question, which is like, can someone, does someone have an idea for how we can make this better?
Maybe we can try caching, and just if a request is made to the server to display the current active games, we can use caching to just give the user the same response repeatedly when there is no change in the number of games that are currently being played, I guess.
Okay, what about if there is a change to the games being played?
Yeah, if there is a change, yeah, I don't know. You'd have to get to the database again.
Yeah, so that's a great idea. So what Salman was saying is, we can we can compute this once the active game is being played. Once the game ends or a new game starts, like we keep track of it. We say, oh, okay, now we know this response is old, and we recompute it the next time we get a hit, right? So this is a great strategy. Anyone else have any suggestions?
Maybe keep information about the games that are currently played as a state on the server. So like, yeah, I don't know how to put it another way. Like, doesn't make sense what I'm saying? Like,
Yeah.
Keeping that information on the server, not storing it in the database, but just the games that are currently played. Maybe it's the same solution that Salman suggested.
Yeah. So what Ilya is suggesting is, actually know ahead of time what games are being played, and keep track of that. When a new game ends, or sorry, when a game ends, remove it from the current games being played. When a game starts, add it to the new games being played. And so you do this very eagerly, rather than computing. When someone requests you, okay, do I need to figure out what games are being played, or can I just use what I had before? So I'm gonna join what Salman and Ilya suggested, and I'm gonna propose that we keep like a separate service called a game cache, okay? And what it's going to do is it's going to be basically like a database, except everything's going to be super fast and super hot in there, okay? Because what we're going to do is every time a new game comes in, we're going to put it into the cache. It's going to be right there, just going to be sitting there. When a game ends, we're going to pull it out, okay? And like it's always going to like all these games are always going to sit in memory. And whenever the server needs to get the active games, all I have to do is like yank everything out of our game cache, right? They don't need to do any searching or anything like that. They can just grab all of them out, because we know like that's kind of the foundation for what we've done. We said you have to, the pre and post condition is that, the only things that are in here are the currently active games at all times, right? And so I hope you can swim a little bit and see, okay, this is a combination of what Salman and Ilya were suggesting. On the one hand, we know exactly what games are currently being played. On the other hand, like we don't need to do any additional work because we have this cache of all the games at any one time, right? Okay, so now let's think about this a little bit deeper. What are the downsides to this approach if we do it? Okay, so yeah, so Skanda says server demand rapidly increases during popular hours. Yes, that's a great point. So one thing that could go wrong is that like now we're just like chucking a bunch of stuff into this guy. And maybe we have to spend a bunch of time just like putting stuff in and removing stuff out, right? For example. Or like if the main memory on this guy gets overloaded, then you have to like throw everything back into the disk, and things start getting slow. And it kind of starts getting like this database would behave. Maybe not so aggressively, but things start slowing down a little bit, and you start having to do a lot of work, especially with removing games and adding new games in. Any other ideas here?
If the game cache goes down, we may lose all of the data about the games that are currently played.
That is a great point. Yeah, there's no recovery from that. Okay, yeah, so Skanda and Ilya make up great points. The other things that I would mention is that it also like just increases the complexity of your application, right? Because like now you have to have like this new component that you have to manage. You have to make sure is up all the time. That, you know, as Ilya mentioned too, you have to make sure that like if it crashes, like you don't want to lose all your states. You need to like have some more. You need to have like even more logic to handle that. Otherwise, your application is just inconsistent. So it's more complicated. Like things start breaking down if there's a lot of load. There's no recovery without additional intervention. If this thing goes down, right? All these things are kind of things that we need to keep in the back of our head. So even though we might have solved this immediate problem of like this thing being super expensive, now we have these additional issues that we need to take into account, right? Okay, but in general, like we can say like this is a pretty good model. You know, at the end of the day, like maybe we had to increase our complexity and we had to like take care of some other issues, but we were able to cache like this very expensive part of the operation of our chess application, right? So now let's think about like some other things that we could cache, right? So we had these 4 features. We had these live one-on-one games. We had live standings of user ratings. We have this display of other games and players. So we talked about how we can cache this part, and we had a chat capability. And I'm going to add one more thing, which is like think about the chess UI itself, right? Like what we serve to display the UI on the user's browser. So we talked about how we can cache this 4th bullet right here. But does anyone have any suggestions on like if there's anything we can cache in these other 4 bullets? In a similar kind of model to what we just did with this game cache cube thing. Okay, so Skanda suggests UI positions since they repeat. Is there any way to store them in a tree or something? Yeah, we could do that. That's actually a good question. I don't know how tractable that would be because your tree might have to be 2 to the 64 nodes large, right? Which probably is not storable, but yeah, that's an interesting question. Maybe someone can play around with that and let us know if that works. Maybe I'll play around with it too. Any other suggestions? Okay.
This is like the same idea as the last one, but we can use client-side caching so that when the user reloads the page and there is no change from the server, we can just like use the cache stored on his on the user side to just like give him that the recent version, because there is no changes made, so we don't need to make requests to the server again.
Yeah, that's a good idea. That is even one that I hadn't really thought of when I was designing this. But yeah, that's a great point. We'll come back to that probably like in the 5th session here, because I do want to talk about like a lot of things we can do on the client side. But so Salman raised a great point. We can cache, we can cache additional information on the client side. The additional things I want to add is like we can also cache pretty much all of our static content. So like, for example, think about like profile images or think about like profile images. You can definitely cache this, right? Because like how often are profile images being changed? They change, somewhat of the time, but very often they stay the same. So it would be good if we could cache this somewhere and have like a very fast lookup rather than having to hit the server every time and ask it, okay, what is this actual guy's profile image? The other stuff is like, if you think about what goes into your UI, and this is kind of getting to what Salman was suggesting, though in a little bit of a different vein, you can oftentimes cache your JavaScript, your HTML, and CSS, especially if those aren't changing super often. Probably the biggest one here is your CSS, right? Because your CSS styles probably don't change too much, even though your HTML layout might, and your JavaScript on the HTML might. But in particular, you can definitely kind of try to cache SSS very aggressively, because it's not going to change super often relatively, and maybe HTML and JavaScript you can cache to a lesser extent. And the other point that I want to make is, so like the static stuff we can almost certainly cache. And the other thing too is that we can think about caching is these live standings that we had, right? So again, let's go back to this idea of like, how often is it the case that you really want to know what your chess rating is right this minute? Maybe you don't care what it is right this minute. Maybe you're okay waiting an hour or so before you know the exact true result, right? And so if we can find, if it's okay for us to kind of like wave our hands a little bit and say, okay, here's what your rating is approximately, but we're not going to tell you exactly until like some time in the future. You can use this buffer time and use like those cache ratings during that time, rather than having to like call a server and look up like the exact current rating, which might incur this cost of like computing the actual rating if it hasn't been processed before, right? So again, stop me if you're not following here. But I kind of want to break this up into two buckets here, and I want to say that, okay, this kind of caching we're going to talk about in the context of something called a CDN, and this kind of thing of like making our live standing a little bit less live in order to get some performance boost. We're going to talk about in the context of batch processing. Maybe we won't have time to get to batch processing today, but we'll go over it next time if we don't. Okay, so again, stop me if you have any questions, but I'm going to move on to CDNs, and also getting interrupted. So the premise here is like, how does our model for delivering content usually work? And I guess this gets a little bit to what Skanda was saying. Skanda was asking earlier about load balancers, but I really don't want to dive into this, so maybe we can ignore that for a second. If we just imagine a single server, as kind of like existing somewhere in space, and it's like a single point of communication for everyone else. The problem with this is that, like, even though we might minimize like the average amount of work the server has to do, or like that, or even the average latency that we have in order to talk to a server, because it's kind of like distributed equal to relative to everyone else, it still might take like a lot of time for this guy over here to talk to the server here and travel back, right? It would be a lot nicer if we could place like a bunch of smaller servers next to everyone, and then the responses are very, very fast, right? Now, of course, the problem with just putting one of these production servers next to like regions that you care a lot about, is that you have to put up a lot of these kinds of servers, right? And if they're all like doing a lot of work, it's going to be really, really expensive, because now you have like, in this example here, we made 5 copies. And so like if this server in the middle cost us, I don't know, like $200 a month, and we make 5 copies of the exact same thing, and we place it at like, these different node locations, now we're spending $1,000 a month for for this low response time. But like, does that directly correlate to like wasting, or does it directly correlate to spending $800 more? I don't know, but I would guess probably not. I don't think it's that big of a deal. But on the other hand, if we can make these servers perform very, very efficiently and very, very cost effectively, then maybe we can decrease their cost, and then maybe we're only spending like 1/5 of the price of what we spent on this original main server, and in that case, this balances, like the cost balances out, and also we get a win in the efficiency of the requests that we're serving, right? So the premise here is that you set up these like smaller nodes called like nodes in this content delivery network, CDN. Each of them basically just serves static content, which is really fast to serve. You don't have to do any additional work. You basically just grab a static file and you throw it back to whoever asked for it. And this can be made super cheap, especially if you're just serving the same file all the time. The file cache in the operating system will always have that file hot, and like it's equivalent to like looking something up in the memory cache. Like you say, okay, I want to know what this JavaScript file looks like. It's like, boom, I have it there for you immediately. I can throw it back right away. No additional work. Like this is a very inexpensive operation compared to dynamic servers that have to like handle a lot of logic and talk to databases and stuff like this. This is like a very self-contained thing that can almost immediately give you back whatever you ask for. And this is exactly the technology that GitHub Pages uses. So if you guys haven't heard about GitHub Pages, it's like this massive CDN that serves static content, or like, yeah, basically you can host arbitrary static content on GitHub. And if you think about this like from a fiscal point of view, it's like, how could GitHub possibly afford to do this kind of thing? The reason that they can afford to do it is because like it costs them almost no money to serve it. And it brings great credibility to their brand. It's like, well, we're giving you this great service for no price at all. The reason we can do it is because the way you can set up these CDN things when they just serve static content is super cheap, and it effectively costs us nothing either, right? So this is a model that works, and if we can bring it to our applications, we're likely to get to see some gains out of it. Okay, so again, I hope everyone kind of followed with this. If you didn't, stop me again. I realize I keep saying this, but I think it's important. I don't want to lose you, basically what I'm trying to say. So we've talked a little bit about the advantages here. Like we've increased the latency, or sorry, we decreased the latency. We can give like faster response times to our customers, et cetera, all this business logic. Your boss loves you, whatever. Let's think about like what some of the downsides of this are, right? Because like you can't have your cake and eat it too. You got to sort of trade off somewhere. So can anyone think of any downsides to this approach?
Probably the main one I can think of is just lack of customizability, because they kind of do it for you. You don't know where you want to, where they necessarily hosting it. So might not necessarily satisfy your users.
Yeah, that's a great point. Especially when you think about like the distribution model, it's kind of tricky figuring out like where exactly to place everything. So thanks, Dimitri. That's a great point. So we have a message in the chat from Skanda and Ilya who say more overhead to distribute static content amongst nodes. Yes, that's also a big problem. You have to deliver all this data to all these like little nodes in your CDN. So if anyone else has any suggestions, let's shout them out. But yeah, let's just to kind of elaborate this a little bit more. So what both Dimitri and Skanda and Ilya said is all correct. I would also add that you got this additional thing that like again your application gets way more complex because now you have all these little nodes you need to manage, and like that's not a trivial thing, right? Like you do have to do additional work. So in our last few minutes, I do want to talk a little bit more about this point on how do we update content, because this is like a real problem too. We do have this issue of like, well, how do we get the static content to our nodes, and how do we know when to update it, right? Because like if someone changes their profile image, like we can't just keep using the old profile image forever, right? Like they're gonna get upset and they're gonna be like, oh my god, this company like isn't representing who I am. and like it's frustrating, right? No one wants to deal with that. So you have to think about this model. So there are there's like two big ideas for how to do this. And in fact, like if you kind of squint a little bit, there's only two ways to do it, right? So one way to do it is like whenever someone makes an update. So let's stick to the profile images example, and you can kind of extrapolate that to any other content that might be served by a CDN, because it's all just static content basically, right? So one idea is like whenever someone updates their profile image on our web application, of course, this updating goes through the server, because like that's the one responsible for updating all the logic and all this kind of stuff. And what the server can do is the server can say, hey, okay, this person just updated their profile image. I'm gonna forward it to all the CDNs, and the CDNs are gonna replace the old profile image that they had with this one, right? So that's one idea. So you just push it all forward. You push forward the update whenever it happens, and the CDNs get it immediately or almost immediately, right? The other idea is you can set up your CDNs, and you can say, okay, you can have this content, for example, all these profile images, but let's say like after 30 days, you have to assume that they might have changed, and you have to ask me again what those profile images look like. So the CDN holds a profile image of like, what's a great figure? I don't know. It holds a profile image of the Mona Lisa. 30 days goes by, it says, oh, the profile image for Mona Lisa might have changed. Let me go ask let me go ask, the web server that I'm correlated with, and ask it what the profile image is again, and I'll just update it from there. So every 30 days you do this process, and then this is how you update your content. Now, again, let's think about like what the trade-offs here are. So if we do this push model, like the nice thing is that we get updates immediately. But the problem with it is like, let's say there's something on your website that is being like frequently updated. Let's say like you're like an avid blogger, okay, and you write like a blog post every single day, or even more kind of esoterically, you write a blog post every hour. So every hour, the web server has to push this content to the CDN, and all of a sudden, this is starting to get expensive, right? Because it's not like you just have like one CDN node, you have like 10 or hundreds of them. So every hour, your web server has to go out and send these requests to all these hundreds of nodes and say, hey, there's a new blog post. You need to update it. You need to update your content with this, right? And if it has to do this for many people, like many different kinds of blogs, this can get really expensive really quickly. You're sending a lot of traffic all the time, and maybe now it's not even as effective as if you just had one central server and we're doing like this longer lookup, because at least if you just had the one server, like it would just be fresh there, right? So that's the problem if you just say, okay, we're gonna have a push CDN. If there's something being updated very frequently, you're not gonna, like, the cost of updating might be very, very high. On the converse, like with the pull CDN, you lower the volume of traffic substantially. You say you're gonna get new data from me every so often, and I know what that so often is going to be. It can be very consistent, and that way, like, I know there's not going to be fluctuations in the amount of traffic that I have, and I can reasonably say, like, okay, it's not going to be so expensive, or it's going to be expensive enough that I can deal with it. Right? You're going to design it in this way. You're going to space out these time intervals so that it's affordable for you. Of course, the downside is, again, like, then if you have something that's being updated very frequently, you're going to get stale data all the time, right? So if someone publishes a blog post, if someone publishes like 5 blog posts in a week, but your timeout for the pull CDN is like 2 weeks, well, then you're not going to be able to see the 5 blog posts until the CDN decides to pull in the new data, right? So we kind of rushed through this, but again, the point I want to make here is, like, there's not a perfect solution to this. We chose a CDN because we wanted to deal with this problem that we had, which is, like, we don't want to hit our server every time we need to get some static content. And we found out there's a much cheaper way that we can do this, just by distributing our nodes in an efficient manner, so that the latency of the request to get static content is very, very low, But even though we were able to do this and get like a nice efficiency gain from it in our web application, we now have this other issue of like, it's not so clear what's the best way to update that static content, and at the same time not deal with the fact that like, we might have to spend lots of time actually pushing data up to update new content from that, right? So again, this is something you have to think about. You have to decide, what does my application need, and what trade-offs will I have to make, okay? Okay, so I'm not going to get to my last topic because we're out of time. At this point, I do want to say, though, please leave feedback for the session if you haven't already. Again, it's very much appreciated. Next time, we're going to go through some more examples and talk about some different things related to system design. It's going to be very similar to what we did today. Hopefully a little bit deeper. But yeah, are there any questions or comments? And if you're like completely lost, be like, Yas, you completely lost me. This was pointless. Come on, right? So, but yeah, if you have any questions or comments of what we talked about, I know we kind of rushed through the CDN stuff, so if you want to talk about this too, feel free.
I had a question about caching mechanism. Like, how's it usually implemented? So, understand that the data is stored somewhere in the memory. Is it like stored directly in the like on the disk, and then whenever we need it, we somehow retrieve it based on some sort of IDs? How's it implemented?
Yeah, so it depends on the content. Let's just say you're storing files. There's like a few different ways you can do it. One thing you could do is like you could like set up some machine that has like, I don't know, some tremendous amount of main memory, like 1,024 gigabytes or something of main memory. You can do this. It's pretty expensive, but you can do it. And you just store like all that file content in the main memory, and you just pull it out of the main memory whenever you get a request, and you chuck it over. And like this is okay. It's not the fastest thing in the world, but it could be much slower than if you were just reading from disk, for example. But reading from disk is not so bad either. So especially if you let's say you have some cache node that's serving like static CSS files, right? What's going to end up happening is that the vast majority of the time, okay, how should I say this? So you're going to get like one CSS file that's going to be requested much more often than anything else, right? Because probably your application has like one main CSS bundle, right, that represents the styles on your web application. And this file is going to get hit all the time whenever someone says, hey, I need the CSS contents for this application. And the really great thing is that like modern operating systems, since about 20 years ago, have had this feature called a file cache, which means that really recently accessed files are going to be cached on the operating system level. And if you go to look them up, it basically costs the same as it would to look up in the main memory to get the file and to send it back. Of course, it's a little bit more expensive because you have to do like all this IO stuff, but like the point I want to make is that like whether you do it from the disk or the main memory, you can still make it fairly cheap. Yeah, I hope did I answer your question?
Yeah, thank you. And what about like the specific problem that we were discussing, like the lead chess problem? If we were talking about that sort of data, not static files, but information about the games that are currently being played.
Right. So I would say like we shouldn't store that data at all. If I said that we should cache like the game data itself, I definitely misspoke. because that's probably something that's not worth caching, right? Because that stuff like maybe doesn't change all the time, but like how often are people looking up a particular game that happened at one point in time? Or are you talking about like the games that are happening currently?
Yeah, the games that are currently being played.
Oh, I see. Yeah, so that's a good question. I guess here it's kind of vague. I didn't really think about this so much. One thing that you could do is you could just say like, okay, like what is like you know, maybe give every game an ID and say like, okay, what are the active game IDs being played? And then you chuck them back over to the UI, and like maybe you have like a lazy loading UI that like, you know, displays that like loads like a feed for a live game like once at a time or something. Or like maybe you have a grid and you just load 3 of them at a time, and if someone scrolls down lower, then you load the other 3. But you have to like know what these games to load are ahead of time. So maybe that's what this game cache stores. It just stores these IDs of games that the UI should load. It gives it back to them, and then when someone scrolls down, you know, to the pane where they can see the live games, the UI is like, the UI hits up the server and says, okay, can you get me like the current state of this game so I can show like a live feed of what it looks like? But at this point, this request to get the live feed might actually be relatively cheap, because if you have like this very specific thing that you're looking for, it's like databases are very efficient at looking up keys, right? So like if you have one exact thing that you're looking for, the database will likely have very efficiently optimized how it knows to look up for that. And so once you decrease what you're looking for to a very high granularity, then you're not spending very much time at all to find out what the game looks like, and you can give the user the display of the game relatively cheaply, rather than having to look everything up all at once. Does that answer your question?
That makes sense. Yeah. So we're sort of storing just the IDs of the games that are currently being played. And then if we need some other information related to the games, we just get them from the database, right?
Yeah. And I'm sure there's plenty of other ways to do it too. This is just probably what comes to my mind the first.
Okay. Yeah, so we are solving the problem of getting the games that are currently being played, like just their IDs.
Yes.
And not the overall information about them.
Yeah.
Okay.
Because I guess also, like, as a quick follow-up to that, like, if you also think about what it would mean to cache like all their information all at once, like then it might get to the point where it's far too expensive to cache that too, right? Because then you would have to like every time someone makes a move, you would have to like update this game cache, right? And let's say there are like 2,000 games being played currently, and a move happens like every 5 seconds. Like it's going to get really expensive to like have to keep jamming things in there. So you kind of have to like find this trade-off again, right? You have to like figure out, okay, what's reasonable for me to do or not do. Yeah. Okay, any other questions? Okay, if you have any, like, feel free to send them in the Slack channel. But yeah, thanks otherwise. Thanks for coming. Hope you learned something. Please leave feedback. I know most of you have left by now, but all right.
Yeah, thank you. It was a good presentation, like good session.
Sure. All right.
Yeah.
Thanks.
See you later.
Take care.